Alright, so in section 2.2, we are looking at how the slope works with respect to rise over run. So remember that it's always the y values over the x values. So we refer to the y as a rise, and we refer to the x values as a run. And so when we look at the actual formula, you have m, which is designated as the slope, or the rate of change in a sense, and the formula is y2 minus y1 over x2 minus x1. Okay, so in this case you have 2 points, and just as an example, if I had the points, let's go with 1, negative 1, and I had another point to connect the line, which was 7, comma 2. Okay, so in this case, let me open this up a little bit, because if I don't have enough room to draw, then we cannot actually do the graph properly. So let me go ahead and I'm going to draw down here instead, and I'm kind of justifying the graph so that I can fit the points. So I'm going to begin with the first point, which is positive 1, negative 1. So I'm right down here. So that's my first point. And my second point is 7, 2. So I'm going to go 2, 3, 4, 5, 6, 7, and then up 2 points. Alright, so you notice that's 1, that's 2. Here's negative 1. Positive 2 for the 7. And obviously 1, 2, 3, 4, 5, 6, 7. And I'm up here. So that's the point 7, 7, 2. And that's your point over here, 1, negative 1. And so this line is in essence going this way. If I wanted to determine the slope, I can use a couple of methods. So what the method they want you to use here is to use x1, y1, x2, y2, and literally plug it into the formula. So if you notice the values, let me pull up the marker. Okay, so here's your y2. I'll circle it instead. So there's your y2. That goes first. Minus the y1, which is negative 1, over the x values. And your x values, you start with x2, which is 7, minus x1, which is 1. Just remember that this value here, this negative, is present because of the formula. So if you notice, I still have negative 1 listed as negative 1. So when I look at my slope here, I'm simply going to say this becomes, double negatives become a positive, so this is really 3, because 2 plus 1 is 3. And 7 minus 1, well, that's going to give me 6 in the denominator. So my slope, rise over run, is 3 over 6, which also reduces to 1/2. Okay, so if I counted it, notice that I'm going to count up 1, 2, 3 over 6. 1, 2, 3, 4, 5, 6. So that's your rise over run. Notice the rise is 3. All the way to here is a positive 3 rise. And that's the top part of your slope. When I go this way, from this point over to this point, all of this is 6. That's this value. Okay? So you can count it or you can write it out. Let me see if I can do another example. Let me go back over here and get another paper. See if I can get another graph. Alright. Alright, so we're going to repeat this process. For example, that was example 2 by the way. I skipped example 1 because it's basically embedded. So here's your question stem for this. It says, in essence, find the slope of the line passing through and then it gives you the points. It literally says the points, and then it gives you the 2 points. So we have 3, negative 4, and we have the point negative 5, negative 1. Okay, so again, the first step I would take is I would label. So you have x1, y1, x2, y2. Again, you're going to use a formula where you have the slope is equal to y2 minus y1 over x2 minus x1. So y2, which is negative 1, minus y1, which is negative 4, and this is over x2, which is negative 5, minus x1, which is 3. So if you notice, these 2 negatives become a plus. This ends up being negative 1 plus 4. So you have negative 1 plus 4, which is going to give you 3. You can also look at it as 4 minus 1 is 3. And minus 5 minus 8, which gives you negative 8 for the bottom. So that means that when I look at this slope, this is equal to negative 3 over 8. And that's all they ask you to do. Since 3 is a prime number, you don't need to simplify. Okay. Now, in the rest of the chapter, we pretty much deal with the same thing. I want to look at example 4. And example 4 basically says, in this case, find the slope of the line passing through. But notice this one has the same x. Oh, I keep drawing a comma. So minus 3 minus 2. So do you notice that in this case these two are both x? And so as a result, if I were to draw this, let's go ahead and draw it first to talk about it, and then we're just going to use the slope formula. Okay. So this point, starting from the origin, is negative 3. Here's negative 3, and I'm going to go up 4. So I'm right here. That's that point right there. Okay. If I do this again, this is negative 3, negative 2, so I'm going to start from the origin, negative 3, but this time down 2. This is why it's negative 2. So if I match these up, that's that point right there. So this is negative 3, 4, and this is negative 3, negative 2. And so this line literally is going straight up and down. Not sure what's happening here. That was weird. One second. Let me go. And back to this. I'm not sure. I guess I lost connection for a moment. Hopefully it didn't affect the video. Alright. So, wow. Okay. There we go. So when I draw the line, that's a straight line going up and down. So this is what we call, that line is called undefined. It's undefined because it goes straight up and down. And the other reason it's undefined is because if I label x1, y1 and x2, y2, and I apply that formula, again, that formula is the slope is equal to y2 minus y1 over x2 minus x1. and I substitute this in, I'm going to get the slope is equal to negative 2 minus 4 over negative 3 minus 3. Okay, so just so you follow the math, the negative 3's are the x values. These values that you see here, the 4 and the negative 2, that's this right here. That's your y2 minus y1. And so when you do the calculation here, you end up with negative 6 over 0. Because that denominator is 0, we refer to this as an undefined or undefined slope in this case. Okay? Okay. Same example 5. In example 5, we have basically the question standard's the same. It's still find the slope of the line. Sorry for the background noise. People don't know to play something. Find the slope of the line passing through, and then they give us 2 points. And then one of them is 0, 2, and the other one is negative 4, 2. So when we go ahead and we actually apply this, do you notice that both of the y's are the same in this one? So what happens here, if I were to graph this just to show you what it looks like, and if I have 0, 2 on here, and if I have negative 4, 2 on here. So this line is actually going horizontal. When you see this, what's happening is that the y values are actually the 0 part. So for this example, you end up with 2 minus 2 over negative 4 minus 0, giving me 0 over negative 4. And that's my slope. So in this case, we just say the slope is 0. Okay? In the first example, what I said was that the slope was undefined. In this one, the x's are the same. Okay, so that's the hint, or the big hint. Now, let's talk about parallel versus perpendicular lines. So, parallel lines, and so this is example 6. Here's what I need you to understand. If the lines are parallel, they will have the same slope. They will have the same slope. If they are perpendicular, we have the negative reciprocal of the slope. Here's an example. If I have a line y equals 1/2 x plus 3, and I have a second line, and that is 1/2 x minus 2, do you notice that they both have 1/2 x, or 1/2 in front of the x, indicating that they have the same slope. Alright, so they have the same slope, they are parallel. That means that they are going to basically look like this when graphed. If I'm talking about perpendicular lines, these lines, you'll see the symbol that looks like this, right? And this is negative reciprocal. Alright, so in this case, this is what the diagram would look like. And when you have something like y equals 1/2 x plus 3, then y equals negative 2x plus 2, for example, you'll notice that this slope is negative reciprocal. I'm going to have to stop the video here because the background noise is unreal.